Hey everyone and welcome to this one short video on differential equation. Before studying differential equation, make sure that you have already learnt about differentiation, integration, indefinite integration as well as definite integration. Then move on to this. We have already uploaded those chapters. Make sure you go and watch them. So let us begin with differential equation now. So firstly, let us talk about the introduction part. When I say introduction, that means the definition of differential equation. So what exactly is a differential equation? So differential equation is an equation that relates a function with its derivatives, right? That relates a function. So basically you need to have a function, you need to have an equation, you need to have derivative. So let us see. Can I say y is a function? Yes. Here we have dy by dx. So can I say we have a function with its derivative, that is dy by dx. Then also can I say we have equality, that is equal to symbol. So yes, this is a differential equation. The conditions are satisfied. Let us have a look. So function is y here, differential equation, differential derivative is dy by dx, and equation is equality, right? And then you have something on the right hand side. You can also have a constant there. You can also have a variable there. You can have a monomial, binomial, trinomial. That completely depends. Okay. So here we can say that differential equations express relationship. So what are they trying to tell us? They're trying to tell us the relationship between what? Between the changing quantities and their rate of change. Obviously here we are talking about the rate of change only, because here we are talking about dy by dx, right? So rate of change, we have studied this in application of derivatives as well. Of course we are going to have some word problems here as well in this chapter, similar to what we have studied. Okay, so let's begin with the types of differential equation now. So the first type is ordinary differential equation. So what is ordinary differential equation? One or more functions of one independent variable and its derivative. Functions with one independent variable and its derivative, right? So here we have dy by dx plus 3y is equal to 3x. So this is a differential equation, but an ordinary differential equation. Why? Because if you see y and x, we have one dependent and one independent variable here, right? So x is an independent variable, y is a dependent variable, and then we have the derivative here as well, right? What is partial differential equation? In partial differential equations, basically, if you see the variables t, u, right? So these are partial differential equations. Anyways, we are not going to talk about partial differential equation in this particular chapter. So whatever we are dealing with in 12th grade is going to be only ordinary differential equation. So this, obviously you should know this, but we are not using it now. We are going to use it in the higher grades later. Okay. So as of now, when I talk about, or when I say a differential equation, I'm talking about ordinary only. So please make a note of this. Okay. Now order of differential equation. Very interesting. Such type of simple questions are also asked in the exam related to the order as well as the degree which we are going to study. So order of a differential equation. The order of a differential equation, what is that? It is the highest order derivative. Highest order derivative present in the equation. We saw an example, right? That is y plus dy by dx is equal to 5x. There we have taken the derivative only once, that is dy by dx. But we can also take it two times, 3 times, 4 times, right? So that can be d2y by dx square, d3y by dx cube, and so on. So that completely depends on the question. It completely depends on what the order of the differential equation is. Have a look at this. We have dy by dx plus y is equal to 0. So can I say dy by dx? We have just differentiated once. So this order is 1, right? So the order is 1. Now observe this, highest order derivative. So here the order is 1, basically this is 1, right? But what about this? Here we have 2. So what is the highest order? The highest order is 2. So we can say that the order of the differential equation here is 2. Simple. And then, so this is the order basically. They just highlighted it. And here if you observe, now notice very carefully, we are not going to make a mistake. This is dy by dx the whole cube. It's not dy cube by dx cube, right? And this is d2y by dx square. So this here, it is 1, we have differentiated once, and here we have differentiated 2 times, right? So clearly we can say that the order is 2. The order is how much? 2, right? So the order of the differential equation is 2. Simple. Not 3. right? We are going to talk about that as well. The power, that is different. That power comes when we talk about the degree, but here we are not talking about the degree, we are talking about the order. So let's not get confused. How many times we have taken the derivative, that is the order. Okay. Alright, so let's continue. Again, the order is 2 here. Now let us talk about the degree of differential equation. So the degree of differential equation is the power of the highest order derivative. Power of whom? Power of the highest order derivative, provided the equation is polynomial in derivatives. Equation should be polynomial. That is a condition, that equation should be a polynomial in derivatives. Okay, let us have a look at an example now. So here dy by dx the whole square plus y is equal to 0. Here we are talking about the degree. Forget about the degree. If I ask you what is the order, you will say the order is 1, right? Because dy by dx, we have just taken the derivative one time. So the order is 1. But if I talk about the degree now, the degree would be the power, right? The power. So degree is 2. Simple. Now observe. Here we have d3y by dx cube. Here we have dy by dx. Now understand the statement first. Power of whom? Power of highest order. So power of highest order. So here we have the order 3. So can I say the order is 3? Here the order is 1. So definitely the order is 3. Correct? So what is the power of this? Can I say the power of this is 1? So the degree will be 1. Understand? The degree would be 1. The degree is not 2 because dy by dx is not the highest order. So to have the degree, you need to have the highest order first. Okay. Yes, so this was an example. And if you see here, in this example, it is 1 basically. Now in this example, definitely the degree of the differential equation, again, the power is 1. So the degree is going to be 1. Simple? Okay. Now we have one more example. Have a look at this example. So here the order is 2 and the degree is how much? The degree is 3, right? Order 2, degree 3. Order 3, degree 2, right? Order 3, degree 2. Have a look at this. 2 is the degree, correct? So in this way you can identify the order and degree of the differential equation, right? Okay. Let's continue further. Let us see an example now. So determine the order and degree of the differential equation. Here we are supposed to determine the order and degree of the differential equation. We can do it very fastly, very easily. Looking at this only, we can identify what is the order and what is the degree, correct? Okay. So dy by dx whole raised to 5 plus 5x d2y by dx square is equal to 0. So what is the order? See, this is first order, this is second order. So obviously 2 is a bigger number. So 2 is the order. And what is the degree? The degree will be 1, right? So let us have a look at the solution. This is given. So the derivative is 2, highest order derivative, and then we can say that the power is 1. Correct? Clear? Okay. Let's continue. Now we have a differential equation. So this is how a differential equation is represented with order n. So if you want to find out the general solution of this particular differential equation, so y is equal to ax plus k is a general solution where k is the arbitrary constant, where a belongs to the set of real numbers. And what about the particular solution? If you want to find out the particular solution, we have y is equal to ax plus k1 or y is equal to ax plus k2, where k1 and k2 are numerical values. Okay, you'll understand this better once we solve problems based on this. Also, if you remember, we have solved problems in definite integration where we find out the value of c, right? Where this is very similar to that, and then we'll find out these values and substitute again to find out the particular solution. Okay. So the general solution of a differential equation of the nth order must contain n and only n independent arbitrary constants. Obviously, of the order n should contain only n arbitrary constants. Okay. Now let us see an example. This is a differential equation. This is a differential equation. So here what is the general solution? Y is equal to 3x plus k, right? where k is some arbitrary constant. And what is the particular solution? Y is equal to 3x plus 2 and y is equal to 3x plus 7. Let us see one more example now. So consider the differential equation dy by dx is equal to 3x square. So what is the general solution? The general solution is x cube plus c, right? Because if you integrate this, you are going to get x cube plus c. You will understand these examples also better once we solve problems based on it, right? Okay, let's continue. Now let us see what are the steps to find out the general solution. So step 1 is solve the differential equation by integrating it. So how do we do this? We solve the differential equation by integrating it with respect to the independent variable. We start integrating with respect to the independent variable, right? And what is step number 2? The step number 2 is we introduce arbitrary constants after integration. So after integration, we introduce the arbitrary constants, right? Okay. Let us see an example now. Find general solution of differential equation dy by dx is equal to 3x square. Dy by dx is equal to 3x square. So what is step number 1? Step number 1 is, firstly, actually this is also called as variable separable method, if you see. So what we will do is we will drag this dx to the other side. That will be your first step, right? So take dx on the other side. So can I say dy is equal to 3x square dx? Now we'll apply our step number 2, which is integrating. So when we integrate, obviously we are going to integrate on both the sides, right? Okay, so let's integrate on both the sides. So integration of dy is equal to integration of 3x square dx. So integration of dy, that is 1. See, that is 1 dy, no? So what is the integration of 1? Integration of 1 is y with respect to, integration of 1 dy is y with respect to y, right? So this is y is equal to 3 is a constant, you take it outside, integration of x square, that is x cube by 3, right? 3 will get cancelled, this 3 and this 3 will get cancelled, and you will get y is equal to x cube plus c. Yes, that's it. So this is the general solution, correct? This is the general solution. Simple. Let us see one more example. So find the general solution of the following differential equation. So we have a differential equation, that is dy by dx is equal to x into under root of 121 minus x square. Again you pull this dx on the other side. Let us see what happens. So taking dx on the other side, you get dy is equal to x under root of 121 minus x square. Now you will integrate on both the sides. How are you going to solve this? Can we solve this by substitution method? Yes, that is one of the ways of solving it. So we put 121 minus x square, right? We put 121 minus x square as some variable. Say for example that variable is t. So if I differentiate, I get x dx is equal to minus 1 by 2 dt, right? So instead of x, I'll put minus 1 by 2 dt, and this inside the square root is t. So you get y is equal to minus 1 by 2 integration of root t dt. Can I say root t is nothing but t raised to 1 by 2? That is t raised to 1 by 2, right? So that becomes t raised to 3 by 2 by 3 by 2. So you solve this further. So this is going to become t raised to 3 by 2 by 3 by 2, and then this 2 will get cancelled, and ultimately you are going to get y is equal to, that is minus of t raised to 3 by 2 by 3 by 2. After cancelling 2, you put the value of t again, and that you get 121 minus x square raised to 3 by 2. And this is your final answer, correct? Very simple. We have just transposed this term to the left hand side, that is why this minus became plus. Okay, let's continue. Now let us see what are the steps to find out the particular solution. So to find out the particular solution, firstly we find out the general solution of differential equation. To find out the general solution. So for general solution, apply the 2 steps that we have already studied. What are the 2 steps? Separate it and then integrate on both the sides. And then step 2 is use the condition. So some condition will be already given in the question, of course, to find out the values of the arbitrary constant. You find out the values of the arbitrary constant, we'll use those conditions to find out the values, right? Okay. Let us see an example. Solve the differential equation dy by dx is equal to 6x minus 4 given that y of 1 is 2. Okay. We are supposed to solve the differential equation dy by dx, which is 6x minus 4, and it is given that y of 1 is 2, right? Okay. Now when conditions are given, you find out the particular solution first. How do we do that? Dy by dx is 6x minus 4, right? So since dy by dx is 6x minus 4, you can take dx to the other side. You get dy is equal to 6x minus 4 dx. Now you integrate on both the sides because we have to find out the general solution first. So let us integrate. So integration of dy is equal to integration of 6x minus 4. Now you know how to solve this further. Integration of dy is integration of 1 dy, that is y. So y will be equal to 6x square. Okay, one more step. So y will be equal to 6x square by 2, and then you will get 6x square by 2 minus 4x. So all the steps, obviously you can show them. If you are able to do it, directly do it, no problem. Directly from here, if you are able to do it, you do it. So now you can solve this further. 2 1s are 2 3s are, right? And this is going to give you 3x square minus 4x plus c. But y of 1 is 2, right? So have a look at this. This is your general solution. So general solution is done. Now we want particular solution. So this is going to be important for us. Okay. Now particular solution, you put y as 1. Sorry, y of 1, that is x as 1. So you get 3 into 1 square minus 4 into 1 plus c, and y of 1 is 2. So here you will put 2, here you will put 2. So 2 is equal to minus 1 plus c, the value of c is 3. Now you put the value of c here, get the answer. Okay, you put it in the general solution, you get the final answer, simple as that. So this is the final answer. I hope this part is clear to all of you. Let's continue. Now let us have a look at one more example. Find the particular solution of the differential equation dy by dx is equal to 4x cube plus 2x. Now again, dy by dx is equal to 4x cube plus 2x. So can I say dy is equal to 4x cube plus 2x dx, right? Simple. Integrate on both the sides. So once you integrate, you can take 4 outside, which is the constant. Integration of x cube, x raised to 4 by 4. Integration of x, x square by 2. Solve it further. 4 4 will get cancelled. 2 2 will get cancelled. You will get x square plus x raised to 4 plus c. X square plus x raised to 4 plus c. Now we need to find out c. This is the general solution, of course. To find out c, it is given that y of x, that is y of 0 is equal to 3, right? So instead of y, you will put 3. Instead of x, you will put 0. Let us do that. So we are going to get y of 0 is equal to 3. That is, you put y as 3. So 3 is equal to 0 raised to 4 plus 0 square plus c. So c is going to be 3, right? So once you get the value of c, you put the value of c here, and then you get x raised to 4 plus x square plus 3, and that is your final answer, right? Okay. So this is the particular solution. So find the general solution. Dy by dx is equal to 2x minus 9 by y plus 1. Okay. So y plus 1 you will take here, and dx you will take on the other side, because we have to take the y terms together, x terms together, right, and then integrate. So we get y plus 1 into dy, that's y plus 1 dy is equal to 2x minus 9 dx. It's not into, don't say into. And then you integrate on both the sides. So y plus 1 dy and 2x minus 9 dx, right? So integrate this. Integration of y with respect to y is y square by 2. Integration of 1 is y. Integration of x is x square by 2. Integration of 9 is 9x plus c. Solve this further, right, to get the general solution. So this is your general solution, right? What do we get? We get y square plus 2y is equal to 2x square minus 18x plus c1, right? So you can transpose all the terms to one side, that is equal to 0, and then this can be considered as your general solution, right, where c is the constant. See, you can take constants on both the sides also, but I'll just give you a simple example. If I take the constant on the left hand side over here, just a random example, if I take the constant on the left hand side over here as say c1, and if I take the constant on the right hand side say c2, once you shift c2 on the other side, can I say c1 minus c2 is anyways going to give you a constant, which is nothing but c. So there is no problem at all, right? Okay, so let's continue. Now let us see the working process to form differential equation. So we'll go very quickly in this. Step 1 is write the given differential equation. Sorry, write the given equation. We are supposed to form a differential equation. Some equation will be given to you. Differentiate it. That means take the derivative this time, not the integration. Differentiate the given differential equation with respect to independent variable x as many times as the number of arbitrary constants. As many times as the number of arbitrary constants. Then eliminate the arbitrary constant with the help of the given equation and the equation obtained by differential equation to get the required differential equation. Okay, this might sound very confusing, but we'll understand once we see the example here. Okay. One thing to note that the order of a differential equation representing a family of curves is the same as the number of arbitrary constants present in the equation corresponding to the family of curves. Now the differential equation representing the curve y is equal to a tan x plus b, where a and b are what? A and b are arbitrary constants. They can take up some values. So the number of arbitrary constants here are how much? 2. Number of arbitrary constants are 2. So what is the order of differential equation? The order of differential equation is also 2. If the arbitrary constants are 2, the order of the differential equation is 2. Let us see an example. Find the differential equation representing the curve y is equal to a cos x plus b. Now see again, if you notice very carefully, how many arbitrary constants are there? There are 2 arbitrary constants here. The 2 arbitrary constants are a and b. That means definitely the differential equation that will be formed here will be having the order 2. How we will see? Okay. So we have y is equal to a cos x plus b. Step number 1 is differentiate it. Let us do that. So dy by dx. Dy by dx is equal to d by dx of a cos x plus b. So what is the derivative of cos? Derivative of cos is minus sign. So can I say this becomes dy by dx is equal to minus of a sin x plus b. Minus of a sin x plus b. Now what you do is you take the derivative one more time, right? Again differentiate. So sin will become cos. So can I say this becomes d2y by dx square, second order derivative, is equal to minus of a, sin becomes cos, cos of x plus b. Now see, we started from a cos x plus b, we ended at a cos x plus b with a minus sign, but what is a cos x plus b? Can I say it is nothing but y? See, so I can put y over here, that becomes minus y. So can I say d2y by dx square is equal to minus y? So shift minus y to the other side. So we get d2y by dx square plus y is equal to 0, right? Okay, you can write it down like that as well. d2y by dx square plus y is equal to 0. Let us see one more example. Form a differential equation from the equation of the family of parabolas y square is equal to 4ax minus h. Okay. Now, where h and a, again there are 2 arbitrary constants, right? So here, the equation contains 2 arbitrary constants h and a. So we'll differentiate it how many times? We are going to differentiate it 2 times, right? Okay, so firstly we have y square is equal to 4a into x minus h. So if we differentiate, we get 2y dy by dx. See, y square becomes 2y dy by dx. We have just opened the bracket here. 4ax, differentiation of 4ax is 4a, and differentiation of 4ah minus 4h, that becomes 0, right? Because a and h, they both are what? They both are anyways constants. Now again we will differentiate. So what will happen? If I differentiate here, same question, second differentiation. So 2, and then if you understand, you will apply UV rule, right? UV rule between y and dy by dx. So y dy by dx, differentiation of dy by dx, plus dy by dx, differentiation of y with respect to x, so dy by dx is equal to 0. Now, differentiating dy by dx becomes d2y by dx square, and this is dy by dx into dy by dx, same thing getting multiplied 2 times, so dy by dx the whole square, correct? That is equal to 0. So that's it. If you want, you can take this 2 on the other side and divide it, it becomes 0. So ultimately we get y into d2y by dx square plus dy by dx the whole square is equal to 0. Okay, let's continue further. So form the differential equation corresponding to y square is equal to m into a square minus x square by eliminating m and a. Eliminating m and a, which are the arbitrary constants here. So the differential equation is given. Again we are going to differentiate it 2 times. Y square becomes 2y dy by dx, right? 2y dy by dx is equal to m times differentiation of minus x square is minus 2x. And then again you have to differentiate it one more time. So nothing much in it, not a big deal. This becomes minus x, 2 gets cancelled, isn't it? And the differentiation of minus x is going to be, minus mx is going to be minus m, right, in the later stages. So have a look at this. This becomes minus m, right? Now minus m, if you recall from the previous steps, was this. So just replace minus m with this and that's it. You get a differential equation. Simple as that. Clear? Very easy. Let's continue. Let us see one more example. So form the differential equation corresponding to y is equal to a cos log x plus b sin log x, right? Okay. So y is equal to a cos log x. Differentiate this, differentiate this. Cos becomes minus sin, sin becomes cos. That is very simple. Have a look at this. So cos becomes minus sin, sin becomes minus cos. But what is the derivative of log x? 1 by x. So we have divided by x. What is the derivative of log x? 1 by x. So we have divided by x, right? So further that becomes dy by dx, right? X dy by dx is equal to, because x we have transposed to the left hand side, minus a sin log x plus b cos log x. Clear? Okay. Now again we will differentiate. So let us differentiate for the second time. This is what we get. Again x will go on the other side. X into x becomes x square, this x, and the common denominator x here becomes x square. And this part, if you remember, if I take minus sign common, then you get y. So we have replaced that with y, and then y we have taken on the left hand side. That's it. Simple. Very easy. And then this is your final differential equation. Now let us talk about first order, first degree differential equation. So obviously if you have dy by dx is equal to some function, then that is first order differential equation. A first degree differential equation means that the highest power of dy by dx is 1. Obviously we know if the highest power is 1, it is first degree differential equation. This is an example. Dy by dx, there is some function, dy by dx plus sin x is equal to 0. So what is dy by dx? We have differentiated it only once. What is the order and degree? The order is 1, degree is also 1, right? So order is 1, degree is 1. Clear? Now what are the methods to solve such equations? That is, what are the methods to solve these equations, as in these differential equations, to get the actual equation? So the methods are variable separable method. One of the examples that we saw previously was of the variable separable method only. So variable separable method, homogeneous equations, linear equations, exact equations. So variable separable method, this is a very important method. We are going to study about that as well. So differential equation of this particular type, that is dy by dx is equal to fx. How do we solve this? We will see that. Then differential equation of the type dy by dx is equal to f of y. So you can have a function in x on the right hand side. You can also have a function in y on the right hand side. That completely depends on the question. The method does not change. It's kind of simple only, similar. And then we can also have the product here, the product of the two functions on the right hand side, f of x into f of y. Correct? Okay. So equations which can also be expressed that the coefficient dx is the only function of x and the coefficient dy is only of y are the types which consider. So these are the equations where we will consider to find out the general solution also. So first order first degree differential equation is of the form dy by dx is equal to f of x comma y. Now f of x comma y, suppose you have something like this, say h of y into g of x. So you will take y together, that is hy and dy together, gx and dx together. So that becomes 1 by h of y dy is equal to gx dx. Simple? Okay. And then you integrate on both the sides, and then this becomes say we have taken it as capital H, and this we have taken is at capital G, and then plus C, some constant, to find out the general solution. But to find out the particular solution, in that case we also find out the value of C, right? So this is the variable separable method. So identify that given differential equation is of this type, suppose, or this type, right? Or it can be of this type, doesn't matter, any type. The procedure remains the same, right? So for 1 and 2, separate them and then integrate. Step 2 is, for 3, the given can be separated like this. We already know that now. We have seen it in the previous slide as well. So this is what you get finally, right? And for particular solution, what you do? For particular solution, you find out the general solution, then you find out the value of the arbitrary constant as well, and then substitute the given values of x and y and find C. Sorry, first you find out the values of x and y, then you substitute the value of C in the general solution. This again we have done in the previous questions. So these are just the steps, you don't have to remember the steps here. We'll see some problems based on it to get a better clarity, right? So find the general solution. See, same examples, we have done it before. Dy by dx is equal to 5y. So this is 5y, right? And this is dy. So obviously we'll have 1 by 5y dy, isn't it? So step 1 is identify the differential equation, the type. This is the type, dy by dx is equal to f of y. See, the function is in y here on the right hand side. We have dy by dx, that is the first order, first degree differential equation. So here I can say dy by dx is equal to 5y, which is dy by y is equal to 5 dx, right? I've just taken y, the variable here. Now we can integrate on both the sides. Once we integrate on both the sides, can I say integration of 1 by y dy is equal to integration of 5 dx. Integration of 5 is 5x. Integration of 1 by y is log y. So can I say log y plus c is equal to integration of 5 dx. So log y plus c is equal to 5x plus d. C is a constant, d is a constant. Anyways, once you subtract the constants, you're going to get a constant only. See, d minus c. Subtract the constants, you get a constant. You can call it as a, right? So yes, log of y is equal to 5x plus a. You can also take this as c1, c2, c1, c2, and then this becomes c. Okay. So finally we get, okay, you can take log on the other side and then you can have e raised to 5x plus a, right? So y is equal to e raised to 5x plus a, right? Where y is equal to k times e raised to 5x, where k is a constant. Clear? Okay. Now let us begin with the solution of differential equation. So let us see this example. We are supposed to solve x square minus yx square dy plus y square plus x square y square dx. Obviously this is equal to 0. Please make a note of this, that is equal to 0. Okay. Because definitely we need to find out the solution of this particular differential equation. That means this should be an equation, right? And if we don't have an equal to sign, this won't be an equation. So this is equal to 0. Okay. So this is equal to 0. I can shift this term on the right, that becomes minus, right? See. So what do I get? I get x square minus yx square dy is equal to minus of y square plus x square y square dx, right? So from here, can I take x square common? Yes. What will happen? I'll get 1 minus y dy is equal to, from here, can I take y square common? Yes. So what will I get? I'll get 1 plus x square dx. Now here we have dy, here we have dx. So definitely y square should come on this side and x square should go on the other side. So let us rearrange the terms. After rearranging, we know that here we have all the terms involving y, here we have all the terms involving x. So before integrating on both the sides, let us separate y square. You can separate y square here, I can separate x square here, x square gets cancelled, so I get 1 by x square is as it is. Now you can integrate, right? So once you integrate on both the sides, you can do it in the previous step also, that is your choice. And then integration of 1 by y, that is y raised to minus 1. integration of 1 by y square, that is y raised to minus 2, and 1 by x square, that is x raised to minus 2. Solve that. Integration of 1 by y, as we know, is log y. This becomes 1 by y, right? And this becomes minus 1 by x. This is x, not y, right? Because we have x square here. And then plus c. Simple. So yes, this is nothing but your solution, right? Okay. Let us see one more example. Again, we are supposed to solve this, that is solution of differential equation. In this is equal to 0. Make sure that you write down equal to 0 here. Same thing, nothing much. You can shift this to the right hand side, that becomes minus of 1 minus e raised to x, x square y dy. Here you have tan y, and here you have 1 minus e raised to x. So 1 minus e raised to x on the left hand side, tan y on the right hand side. So you are going to get 3 into e raised to x by 1 minus e raised to x dx is equal to minus of 1 by y, 1 by tan y x square y dy, right? Now you know what you need to do, just integrate on both the sides. Tan y is already here. The derivative of tan y is x square y. So you can do this by substitution also, that is log of tan y directly. And here also the derivative of e raised to x is e raised to x. So after solving this, you know how to do this. This becomes 3 log e raised to x minus 1 is equal to log of tan y, and then obviously c can be written as log of c, right? That constant can be written as log of some number. That can be further solved, right? If I shift log of tan y to the left hand side, we know that log a minus log b is log of a by b. So this becomes log of 3 goes at the top here, e raised to x minus 1 the whole raised to 3 by tan y is equal to log c. So definitely here I can say that e raised to x minus 1 the whole cube by tan y is equal to c, right? This is what we get. Now let us talk about homogeneous differential equation. So a function f of x, fx comma y, sorry, in x and y is said to be homogeneous function of some degree, say n, if degree of each term is n, that is degree of each of the terms is the same, then only the function is said to be homogeneous function, right? So homogeneous function f of degree n is expressed as x raised to n f of y by x, x raised to n f of y by x. This is how you express a homogeneous function, right? Let us see an example. So f of x comma y, that is x square plus y square minus xy. See, here the power is 2, here the power is 2, x is 1, y is 1, so the total power is 2. So this is a homogeneous function of degree 2, right? This is a homogeneous function of degree 2. Now let us see some examples. Show that the differential equation x minus y dy by dx is equal to x plus 2y is a homogeneous differential equation, right? We are supposed to show that this is a homogeneous differential equation. Let us see how to do that. So to prove that the above differential equation is a homogeneous differential equation, what we will do is we will substitute x as lambda x and y as lambda y. So x minus y dy by dx is equal to x plus 2y. This is already given. So can I say dy by dx is equal to x plus 2y by x minus y, right? We have just transposed the term there. Now, so this is function f. What are we going to do? We are going to substitute x as lambda x, y as lambda y. Once we do that, lambda gets outside, it gets cancelled. So can I say f of capital F of lambda x comma lambda y is nothing but x plus 2y by x minus y. But this is same as what? This is same as your f of x, right? So f of lambda x comma lambda y is equal to f of x comma y, isn't it? So we can say that this is a homogeneous differential equation, correct? Okay. Now we will see how to solve problems based on homogeneous differential equation. For that, firstly what we do is we substitute y is equal to vx. You can take it as anything, ux, vx, doesn't matter. For safer side, let us keep it as vx only in the differential equation. Now y is vx, so definitely we'll apply uv rule. We are differentiating with respect to x here. So can I say dy by dx, differentiating with respect to x, product rule, v derivative of x is 1 plus x derivative of v with respect to x is dv by dx. So dy by dx becomes this. What we will do is, we'll substitute the values in the given differential equation, right? We'll substitute the values where whatever differential equation is given to you, we'll substitute this there. After that, we'll simplify and then separate the independent variables. After that, we are going to simplify and separate the independent variables. You have already done this. You know how to do that. And then the differentiable variable on either side of the equation, that is either side of equal to basically. This also we have studied how we take dy dx on the other side, x terms, y term on the other side and then solve it, right? So can I say this is v plus x dv by dx is equal to vx by x, which is nothing but v. So x dv by dx becomes equal to 0 because this gets cancelled, right? That is dv is equal to 0. The third step is we integrate the differential equation and then we find the general solution in v and x. Third step is again the same. We need to integrate and find out the general solution in v and x, right? So after integrating on both the sides, obviously integration of dv is 0. So v is equal to some constant 0 plus c, right? Then whatever the value of v that you get, you put it back to get the final solution in x and y, right? So we know that y is equal to vx. So what is v? V is y by x, right? So if v is c, can I say y by x is c? And then you get y is equal to cx, right? We have one more example. Show that dy by dx is equal to x minus y by x plus y is a homogeneous and find the particular solution. Here we are supposed to find out the particular solution. That means what? We are supposed to find out the general solution first. After we get the general solution, we'll substitute the values to find out the value of c and then we will resubstitute the value of c at the end, right? Okay. So this is the given equation. Dy by dx is equal to x minus y by x plus y. So f of x comma y is x minus y by x plus y. We know how to show this as a homogeneous equation. We put x as lambda x and y as lambda y and we should get this only again. So we do that and then after taking lambda common, lambda gets cancelled, right? So we get lambda raised to 0 which is nothing but 1 of course, and that is x minus y by x plus y. So can I say from here f of x, which is the given differential equation, is a homogeneous function, right? Okay. Now we put y is equal to v of x. Once we put y is equal to v of x, we know that dy by dx becomes v plus x dv by dx. So instead of dy by dx, you can put v plus x dv by dx. Continue here. So this is already given. So v plus x dv by dx is equal to x minus y is what? Y is v of x. Y is what? Y is vx. Not v of x, vx, sorry. You get x common. You get x common from here. You solve that. You get 1 minus v by 1 plus v. You shift v on the other side. So x dv by dx is equal to 1 minus v by 1 plus v minus v. And then you take dv terms, v terms together with dv and x terms together with dx. So this further becomes 1 by x dx. Okay, solve this. On the right hand side, it will become 1 by x dx. And then on the left hand side, this is what you get, right? Continue further. Now how do we solve this? After integrating on both the sides, here what we have done is, we have just adjusted, we have multiplied by 2 and divided by 2, right? In fact, we have multiplied by minus 2 divided by minus 2. So this becomes minus 2v, and in the denominator, you get 2, right? And this is log x plus log c. On the right hand side, integration of 1 by x is log x. Now to solve this further, what are you going to do? We'll have minus 1 by 2 log of, the derivative of this is there in the numerator. So directly log of 1 minus 2v minus v square. Minus 1 by 2 is as it is, right here. Log. So no, you know how to do this. This is log of a into log of b. So that will become log of x into c, right? See, log of x into c. This is also there. You need to equate these two logs. So once you do that, you equate the logs. Don't cancel it, just for your understanding. This is what you get. Now x is 1, y is 1. So definitely x is 1, y is 1 is already given to you. General solution is done. but we don't want a general solution. Here in this case, we are supposed to find out the particular solution at a particular value when x is 1 and y is 1, right? So definitely we need to put the values of x and y as 1 over here. Let us do that. So if I put x as 1 and y as 1, what will happen? See, we have cancelled this, by the way. So we get the value of c as -2, right? So once we get the value of c, what are we going to do? After getting the value of c as -2, we are going to put this in equation number 1 over here. So let us put the value of c as -2. What will happen? X square minus 2xy minus y square is equal to c, which is -2. And you can keep that as your final answer. Now let us move on to what is linear differential equation. Okay, what do you understand by the term linear? Linear means 1. So whenever the degree of the equation is 1, it is called as a linear differential equation, right? Okay. So differential equation is said to be linear if the dependent variable and the differential coefficient occur in it in the first degree only. So as we are talking about 1 here we are talking about the degree. In lower grades also we have studied about the linear, right? Linear equations. Power of x is y, the power of 1 is y. Here we are not talking about the basic equations, we are talking about the differential equations. So same thing, instead of an equation you will have a differential equation in the first degree only, and they are not multiplied together. Of course, because if they are multiplied together, then for example I'd say x into y, we add the powers there, right? So here also the equations should not be multiplied, right? Okay. Equations as in differential coefficient should not be multiplied, not equation. Equation won't be a right word here. So dy by dx plus py is equal to q, right? So there is no power of y, no power on the differential coefficient. See, there is no power means there is 1 here, and this is also 1, right? So power is only 1. No y square, y cube, we don't have under root. Under root, so anyways, we are not going to have, and it's just plain y basically. Now let us see an example. We have dy by dx plus y square is equal to 5x. So this is a linear differential equation or not? This is what we are supposed to identify. So observe the power of y here. What is the power of y? Can I say the power of y is 2? Since the power of y is 2, we can say that no, it is not a linear differential equation. Clear? Simple? Okay. Let us see one more example. We have dy by dx plus y is equal to e raised to x. Is it a differential equation or not? What is the power of y? Power of y is 1. What is the power of dy by dx? 1. See, so this is a linear differential equation because the power of dy by dx and y both is 1. Clear? Now, is this a differential linear equation or not? Looking at this, you might say the power of y is 1, the power of dy by dx is 1, and yes, it is a linear differential equation. But no, it is not the case because they both are in multiplication. We are taking the product. So whenever we have a product like this, we'll say that this is not linear differential equation because differential coefficients and variables are multiplied together. See, differential coefficients and variable. The variable is y, differential coefficient is dy by dx, which is multiplied together. So this is not a linear differential equation. So I hope you are understanding the difference between when a equation or a differential equation is a linear differential equation and when it is not, right? Simple? Okay, let's continue further. Now let us see some of the methods of solving these linear differential equations. So firstly, we will simplify. What we will do is we will simplify and write the given differential equation in the form of dx by dy plus py is equal to q. So where p and q basically they are numeric constants or functions in x. They are either the functions in x or they are simply numerical constant. They can be constant, right? Okay. Step 2 is we'll find out the integrating factor. Now how do we find out the integrating factor? The integrating factor of a linear differential equation is found like this. e raised to integration of p dx. See this p can be a constant, p can be a function in x also, it can be x square. So we will have e raised to integral of e raised to x, sorry, e raised to integral of x square dx if p is x square. I hope you are getting the point. So p is either a constant or p is either a function in x. That's it. It should not be anything apart from that. Okay. So that is how you find the integrating factor. After finding the integrating factor, now we can write the solution of the linear differential equation as follows. That is y is equal to q multiplied by integrating factor into dx. Obviously, we will have dx here. This is in x plus c. Correct? This might sound confusing here, but once we solve problems based on this, this will become very easy. So definitely we need to see some examples. Before that, when linear differential equation is of this form, which is obviously a linear differential equation, and p and q are functions of y, where p and q are functions of y or constants. So what to do in that case? In the first case we saw p is a function of x or it is a constant. Now it can be y or constant. So the solution of linear differential equation is given by, now we will get x is equal to, there we had y is equal to. If you see the previous slide, see, this is y is equal to q into integrating factor dx plus c, and when we have this function in y, in that case you will have x is equal to q, this part, q into integrating factor dy plus c, right? So this is how we will solve. So depending on the question, you have to identify first p, q, right? Is p in x, is q in y or not? Okay, let us see an example. So solve the differential equation dy by dx plus y is equal to x. We are supposed to solve this. Firstly tell me, is it a linear differential equation? Is it a linear differential equation? Yes, because power of y is 1, power of dy by dx is 1. So definitely yes, it is a linear differential equation. Now, dy by dx plus y is equal to x, right? So if I compare this with dy by dx plus py is equal to q, right? This is the general form. This is the general form, dy by dx plus py is equal to q. Dy by dx is as it is. Can I say p is 1? See, p is 1. And what is q? Q is x. So we get p as 1 and q as x. So p is basically a constant here. So the integrating factor will be given by, integrating factor is equal to e raised to p dx. Why? Because this is a constant. And recall, whenever we have p as a constant, the integrating factor is given by e raised to integration of p dx. That is e raised to integration of 1 dx. So e raised to integration of 1 dx, what is integration of 1? Integration of 1 is x. So we get e raised to x, right? So integrating factor is e raised to x. Once you get the integrating factor, you know what you need to do. Y is nothing but q into integrating factor dx plus c. Okay, q is x, correct. So y is equal to, that is y of e raised to x is equal to, q is x, integrating factor is e raised to x plus c. So this becomes y is equal to, here you need to take what? The product rule, right? And you know how to solve the product rule. That is uv, u into v, or u dot v I can say, integration of uv, u integral v minus integration of derivative of u into integral of v dx, right? So this is what we solve. Solve it further and you get y is equal to x into e raised to x minus e raised to x plus c. You can take e raised to x common if you want. That gives you e raised to x common, x minus 1 plus c, right? So this is your final answer. Let us see one more example now. The question says, solve the differential equation x dy by dx minus y is equal to 7x raised to 6. Okay. So the given differential equation is x into dy by dx minus y is equal to 7x raised to 6. Firstly, can I divide by x on both the sides? If I divide by x on both the sides, I get dy by dx plus minus y by x is equal to, this becomes 7x raised to 5, correct? So can I say this is of the form dy by dx plus py is equal to q? Yes. So what is p? P is minus 1 by x. See, p is what? P is minus 1 by x, right? Since p is minus 1 by x, again you know how to find out the integrating factor, right? So this becomes minus 1 by x, and q is what? Q is 7x raised to 5. Now, integrating factor is going to be e raised to log of minus 1 by x. So let us do that. So e raised to p dx, that is minus 1 by x. Let us put that. So what is the derivative of 1 by x? Sorry, what is the integration of 1 by x? Log x. So this becomes minus of log x, right? So e raised to minus of log x. Minus goes here. E raised to log of x raised to minus 1. E raised to log of x raised to minus 1. So can I say e raised to log of x raised to minus 1 is nothing but e raised to log of 1 by x. E and log will go away and 1 by x will be remaining. See, once you get the integrating factor, now you know what you need to do. You need this q, you need this integrating factor, so you get y is equal to, right, q into integrating factor dx plus c. So that is equal to y by x is equal to integration of 7x raised to 5 into 1 by x. This will get cancelled. This will become 4. Integrate 7x raised to 4, that is x raised to 5 by 5, right? So once you get x raised to 5 by 5, now this is what you get, right? So if I take x on the other side, I get 7 by 5 x raised to 6 plus c into x, right? So the solution of the differential equation is given by 7 by 5 x raised to 6 plus cx is equal to y. I hope this part is clear to all of you. Simple. So all we need to do is identify p or identify q. P can be in terms of x, p can be a constant, or q can be a constant, q can be in terms of y as well. Okay. Now let us see a different question. So here we have dy by dx plus y by x is equal to log x. Now dy by dx plus y by x is equal to log x, right? So this is the given differential equation. Again we can compare this with dy by dx plus p of y is equal to q. So what will be p? P will be 1 by x. What will be q? Q will be log x, right? So again we know how to find out the integrating factor. The integrating factor is equal to e raised to integration of p dx. What is integration of p? Integration of p is integration of 1 by x. What is integration of 1 by x? Integration of 1 by x is log x. So e raised to log x, right? E and log will go away, of course. You will just get x. Now you take this x and multiply with log x on the right hand side. As we know that y into integrating factor is equal to q into integrating factor plus c. So y remains as it is. Integrating factor is x. So y into x is equal to integration of log x into x plus c. So here you will apply the product rule, right? Again we are going to apply LIAT here, L-I-A-T, logarithmic, inverse, algebraic, trigonometric and then exponential. So it is already in order, right? So let's keep it in order. Let's integrate that using the UV rule and then solve this further, right? This is what we get. And that's it. You can keep this as your final answer. So for this also you need to know the chapter thoroughly of indefinite integration. So that is why I told you in the beginning also that to solve the problems based on definite integration, we need to know the concepts based on indefinite integration as well and definite integration as well to solve the concept based on differential equation basically. Okay. Let us see one more example. Solve the differential equation. So here we have xy plus 2y cube dy by dx is equal to y square and y of 1 is 1. This is given. Okay, let's continue. This is the given differential equation, right? So once this is given, can I say from here x plus 2y square dy by dx is equal to y after dividing by y on both the sides. Here I am dividing by y, here I am dividing by y. So you solve that and you know how to do this. X plus 2y square dy by dx is equal to y. So here, further if I shuffle the terms, I get dy by dx, or else I can take dx by dy on the other side. Dx by dy is equal to x by y. I'll pull y down and y square y will become 2y, right? Now, what we need to do? We need to shift this x by y to the left hand side. Now I have dx by dy. I don't have dy by dx, right? So once I have dx by dy, I know what I need to see. I need to see q here. So if I compare this with dx by dy plus px is equal to q, what is q? Q is 2y in terms of y, isn't it? See, q is 2y. And what is p? P is minus 1 by y. Now we will find out the integrating factor, that is e raised to p dy, right? So let us do that. That is e raised to integration of minus 1 by y dy. Again, you are going to get log y only here. And e and log will get cancelled. Y raised to minus 1 is 1 by y. So you get 1 by y here. That is your integrating factor. And once you get the integrating factor, now you know how to find out the solution. The solution is given by x into integrating factor is equal to integrating factor into q dy plus c, right? That is x by y is equal to, this gets cancelled, this becomes simple now, integration of 2, but that is 2 dy not dx, right? So that will become 2y. So y into 2y plus c, y will go on the other side, and this is the general solution. But here we have 1, right? So y of 1 is 1. So definitely to find out the particular solution, x is 1 and y of 1 is also 1. So y is also 1, right? So put x as 1, y as 1, you get the value of c. Once you get the value of c, you have to again substitute it in the general solution here. That is minus 1. So put it there, you get x is equal to y into 2y minus 1, right? That becomes your final answer, right? Okay. Now let us see some of the applications of differential equation. So application is used for finding out the population growth, the rate at which population is increasing or decreasing, the model radioactive decays, the time, then Newton's laws of cooling, then under gravity electric circuits. So let us see a problem based on this. The slope of a tangent, at a point, So there is a point P, x comma y. The slope of that on the curve is minus of 3x by 5y. The slope is given by minus 3x by 5y. If the curve passes through the point 2 comma minus 1, find the equation of the curve. We're supposed to find out the equation of the curve that passes through the point 2 comma minus 1, and the slope is minus 3x by 5y. Slope is nothing but dy by dx, right? So dy by dx is already given to you, right? So the slope of the tangent is minus 3x by 5y. So can I say dy by dx is equal to minus 3x by 5y? Now this you already know how to solve by variable separable method. You take y on the other side, x on the other side. So 5y dy is equal to minus 3x dx. Integrate on both the sides. So integration of 5 dy is equal to minus of 3 integration of x dx. Yeah, you can solve this further easily. So that becomes 5y square by 2 is equal to minus of 3x square by 2 plus c. But now understand what is given. After getting this, it is given that the point passes through, the curve passes through the point 2 comma minus 1. Basically x is 2, y is minus 1. So substitute the values of x and y here. So we get 5 into minus 1 square is equal to minus 3 into 2 square. See, x is 2, y is minus 1. Put it here, get the value of c. Once you get the value of c here, the value of c is 17, right? Now you put the value of c in this particular equation number 1. So c is how much? 17. Put it there. So you get 5y square is equal to minus 3x square plus 17. That is 5y square plus 3x square is equal to 17 is the required equation of the curve. Correct? Simple? Okay. Now the next question says a population grows at a rate of 2.25% per year. How long does it take for the population to double? The value of log 2 is given to us, that is 0.301. Okay. The population is growing at what rate? rate is given, right? That is 2.25. So can I say rate of change? So dp by dt, that is rate of change of population p with respect to time t. Rate of change of population with respect to time is 0.0225 p, right? Now, so can I say dp by p is nothing but, if I take p down and dt there, that is 0.0225 dt, isn't it? Then if I integrate on both the sides, I get integration of 1 by p dp is equal to integration of 0.0225 dt, right? So this becomes log p and this becomes into t plus c because with respect to t, right? Now log p is this. Now we need to find out the value of c as well. But we can say that when the time period is 0, when the time period is how much? 0, the population is p naught. So at 0, can I say this log of p naught is c, because this becomes 0, time frame is 0, and then log p will be equal to 0.0225 t plus the constant, which is nothing but log of p naught. Now if I shift p naught on the other side, p naught on the other side, log of p minus log of p naught is log of p by p naught is equal to 0.0225 t. P naught is nothing but p0, the initial population, you can say. Okay. Now we need the population as double, right? So if the population is double of this, p0 is the initial population. If I double this, that is double of p naught. So can I say this becomes 2? So log of 2. So once you solve this further, just get the value, substitute, and then final answer that you get is 13.377 years. So yes, how long does it take for the population to double? The answer is 13.377. That is the approximation, right? So that's it for today. I hope you have understood the concepts based on differential equation. But before solving the problems based on differential equation, make sure that you understand derivatives, that is differentiation, very well, integration, which is indefinite integration as well as definite integration, and then move to this chapter. So make sure that you watch those videos as well. Thank you. We'll continue the series next time.